In this lesson, we're going to look at graphing exponential functions, but in particular, we're going to be looking at translations. So we're going to talk about vertical translations and horizontal translations. We've already talked about these translations with other functions in previous lessons, but we're also going to talk about in terms of exponential functions. So let's look at an example. So suppose I wanted to graph the following function. All right, so suppose our function is this, f of x equals 3 to the x plus 2. So just as in previous lessons, we're going to, first of all, graph the parent function. And so the parent function would be 3 to the x. So remember, the parent function here is 3 to the x. So y equals 3 to the x. So let's go ahead and graph the parent function. And so the parent function, we're going to graph first. So remember, we're graphing y equals 3 to the x, right? So notice that when you graph y equals 3 to the x, remember all exponential functions have a horizontal asymptote. So the horizontal asymptote for the parent function here is just the x-axis because there's no constant here. You don't see a plus or a minus c. So the horizontal asymptote is the x-axis. And so when we graph the parent function, remember the horizontal asymptote is the x-axis. So when drawing the when drawing the horizontal asymptote, we're going to denote that by dotted line. Now, obviously, you can't see this very well, but notice I'm drawing a dotted line here. So to graph the parent function, we're going to do this. So we have x and y, and we're going to pick some points. So if x is 0, always use 0 when dealing with the parent function. So when x is 0, I get 3 to the 0, which is 1. So when x is 0, my y value is 1. Choose 1 as well. When x is 1, I get 3 to the first, which is 3. So I'm going to plot the point 1, 3. Let's use 2. When x is 2, I get 3 squared, which is 9. And then after that point, it gets so huge that there's not enough lines here to represent those points. So let's use some negative numbers, though. So when x is negative 1, I get 3 to the negative 1, which we know is 1/3. When x is negative 2, I get 3 to the negative 2, which we know is 1 divided by 3 squared, which is 1/9, and so on. Okay? All right, so that's enough points for our parent function. And so we're going to plot those points. So here's what we're going to have. So we have 0, 1. We have 1, 3. 1, 2, 3 right here. So each mark is going to represent 1 unit. We have 2, 9. So 2, 9, 3, 4, 5, 6. I'm going to put a 6 here. 6, that's a 6. 6, 7, 8, 9. All right. And then on for negative x values, we have negative 1, 1/3, which is about here. We have negative 1, 1/9, which is about here, and so on. Okay, what I want you to notice, though, and we've talked about this in some of our lessons on exponentials when you are graphing exponentials, that when you graph these, remember on this side, it rises very rapidly. Okay, so it rises exponentially. It rises very rapidly. All right, so just do something like this. And on this side, remember the graph gets closer and closer and closer to the horizontal asymptote without crossing it or touching it. So don't make it look like it crosses it. It's not supposed to. Okay, so remember all of these y values, all of those y values will be positive. So it will never be negative. So it should never cross the x-axis. So it gets closer and closer to the x-axis. In fact, for the parent function, it'll never equal 0 either. So it's always going to, when dealing with the parent function, your y values are always going to be positive because remember, the base is positive, right? And it's not equal to 1. Remember, the base cannot equal 1. And a positive number raised to any exponent, positive, negative, or 0, is always a positive number. All right, so there's the parent function. So this is y equals 3 to the x. Okay, now I want to use transformations to do this. So what I want you to say is this. Okay, so I want you to say take the parent function. We're going to take y equals 3 to the x and shift it vertically up 2 units. So every point in that graph, we're going to shift up 2 units, even the horizontal asymptote. So when you graph um, the function I want to graph here, here's what you're going to do. So here's the graph. You're going to shift the horizontal asymptote up 2 units. So we have 1, 2. So here's my dotted line. Okay. Now be careful. I'm not saying this is the new x-axis, right? Because this is the x-axis. The horizontal asymptote for the parent function happened to be the x-axis. But for this function, my horizontal asymptote is y equals 2. All right, so y equals 2. So you're going to say y equals 2 here. So that's my horizontal asymptote. Okay? Every point on this graph you're shifting up to. So you see this point that's already given? Move it up to 1, 2, right here. See this point? Move it up to 1, 2. See this point here? Move it up to 1, 2. And all you do, remember it gets closer and closer to the x-axis, right? So do something like this, and then just carefully graph this portion right here. Graph this portion, and there you go. All right, so that's the graph of this right here. The orange one is f of x equals 3 to the x plus 2. So you shift the parent function up 2 units. All right. Okay, so that was after. Now let's suppose you want to graph this. And remember when just to remind you, and I wrote it out right here, when indicating the horizontal asymptote, don't say 2. You got to say y equals 2. The horizontal asymptote is a horizontal line, just like the vertical asymptote, or the axis of symmetry. When we talked about graphing quadratic functions, the axis of symmetry is a vertical line. You have to name the vertical line x equal. The horizontal asymptote is y equals, so y equals 2. All right, so the horizontal asymptote is y equals 2. All right, so let's do number 2. Suppose number 2, you want to graph this function, g of x, which is 3 to the x minus, let's do 4. 3 to the x minus 4. Okay, so again, you do the parent function, which is already given, right? So the blue part is, or the black part is the parent function. So all this says right here is I take the parent function, which is 3 to the x, so take y equals 3 to the x, and shift it down 4 units. Okay, so shift it down 4 units. So we're going to take that black graph, the parent function, and we're going to shift it down 4 units. So remember, all exponential functions have a horizontal asymptote. And so let's move it down 4 units as well. So 1, 2, 3, 4. So here's my horizontal asymptote. I'm going to use a different color. So let's go ahead and use blue. So I'm going to shift it down 4 units. 1, 2, 3, 4. So there's my horizontal asymptote. So it'll be y equals negative 4. Okay? And then we take all these points here on the parent function. I'm going to shift it down 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay? All right, so remember this side gets closer and closer to the x-axis, to the horizontal asymptote, excuse me, and then just carefully do the best you can. Make it look like it's increasing rapidly, just like this. Okay, and there's that graph. All right, so this right here is the graph g of x equals 3 to the x minus 4. All right, so that's how you do that. Okay. All right, now, so it's pretty easy to graph a vertical translation. Pretty easy. Now let's remind ourselves how to graph a horizontal translation. So let's see this example. Oh, by the way, so be careful before I go on. Most students seem to think that an exponential function, as you go from left to right, always increases. That's not true. Okay, so you can decrease. All right. So notice the reason why, and this is one of your lessons that we talked about, the reason why it's increasing here is because if you look at the base is a number greater than 1, right? And so since that base is greater than 1, that's why it's increasing. But if this base was a proper fraction, like 1/3, let's look at that. I just want to show you something. So if the base is 1/3, so for example, if you wanted to graph, let's see, if you want to graph this, f of x equal 1/3 to the x, all right? So if you want to graph that, so remember the horizontal asymptote, there's no number here, so the horizontal asymptote is the x-axis. So remember an exponential function, all exponential functions have a horizontal asymptote. Horizontal asymptote, asymptote. Asymptote is the x-axis, or you can say y equals 0. So when I graph this, and let me go ahead and graph it on this. All right, so when you graph this right here, let's do it this way. So we're going to graph y equals 1/3 to the x. All right, and just look at a t-table. So when x is 0, I get 1/3 to the 0, 1/3 to the 0, which we know is 1. When x is 1, I get 1/3 to the first power, which is 1/3, right? When x is 2, I get 1/3 to the second power. And remember, 1/3 times 1/3 is 1/9. All right, and then when x is -1, I get 1/3 to the -1 power. Now you've got to remember your properties of exponents from a previous course. So if that exponent is negative, to make that exponent positive, all I need to do is take the reciprocal of this base. So the reciprocal of 1/3 is 3. So you got 3 to the first, which is 3. Okay. If x is -2, I got 1/3 to the -2nd power. So again, I have a negative exponent. To make that exponent positive, I can take the reciprocal of the base. The reciprocal of 1/3 is 3. So I get 3 squared, which is 9. And so what happens on this side, I want to show you, is that when you, let's just do it in order. 0, 1 is here, right? Oh, and by the way, here's your horizontal asymptote. Notice I'm denoting that by a dotted line. So that's the x-axis, or y equals 0. So remember, the x-axis and y equals 0 are the same line. When x is 1, I get 1/2. So notice, see right here, 1 1/2. I did. This is supposed to be 1/3. Excuse me, 1/3. So 1/3 right here. When x is 2, I get 1/9. See how it's getting closer and closer and closer to the x-axis? So it looks something like this. All right. Don't make it look like it crosses it or touches it, okay? Don't do that, because if you make it look like it crosses a horizontal asymptote, you will not get all your points. All right, so be careful. And on this side, notice that when you go to the left, it rises rapidly this side. As you go to -infinity, it rises rapidly. So when x is -1, you get 3. When x is -2, you get 9, like this. All right, and then just best you can with graphing this part, okay? You have a pencil, so always erase if you have to. So do the best you can, like this. All right, and so there's the graph. Y equals 1/3 to the x. So notice it decreases because of the base. So the base is 1/3. It's less than 1. It's a proper fraction, less than 1, and that's why it decreases. Okay, so as x gets bigger and bigger and bigger, those y values get smaller and smaller and smaller. It gets closer and closer to 0. It never becomes 0 because there is no number for x in which a number raised to some exponent is ever going to be 0. All right, so if this is positive, a positive number raised to any exponent is always going to be positive. It will never be negative, and it will never be 0. Okay, as long as it looks like this. All right, so obviously if you're subtracting something from it, then yes, at some point it will be 0, right? Okay, So just like this. I just want to remind you. See right here? So you see how this is my function? So you do have an x-intercept, don't you? So there is a place for this one where my y value is 0. But what I'm saying is that if there's no number on the outside, then if you think of this as a parent function right here, 1/3 to the x, your power, oops, we don't call it a power function because it's not a power function. It's an exponential. But whenever you have some number raised to just the x power, this y value will never be negative or 0. Okay, so that's what I want to remind you of. So if your base is a number greater than 1, it's going to increase. If your base is a number less than 1, a proper fraction, 1/3 is less than 1, it's going to decrease. Okay? All right, now let's look at horizontal translation. So we talked about a vertical translation. Now we're going to look at horizontal translation. So let's talk about horizontal translation. So remember in a previous lesson when we talked about translations, vertical and horizontal, when you see something like this where the x minus 3, see where negative 3 is with the x, that's a horizontal translation. So we have y equals f of x minus 3. So remember, that's a vertical translation. So that says you take f of x and you move it down 3 units. So this is a vertical translation. All right, now when it's horizontal, it looks like this. So this is a horizontal translation. But remember, it's counterintuitive. So we see x minus 3. That does not mean you shift the graph 3 units to the left. It's actually shifting it 3 units to the right. So it's a horizontal translation. Horizontal translation. You shift f of x, in this case 3 units, to the right. Okay? So if you have y equals f of x plus 3, all right, so remember that's a horizontal translation. So you're going to shift f of x 3 units to the left. So remember the horizontal translations, oops, left, L-E-F-T. So remember the horizontal translations are counterintuitive to what you would think. Vertical is easy. You take f of x, shift it down 3 units. So this would be shift f of x down 3 units. And then if you had y equals f of x plus 3, then that's again vertical translation. And you would shift it up 3 units. Okay? But with horizontal, this is what it looks like. All right, and it's counterintuitive. So then let's go ahead and graph this now. So let's go ahead and graph f of x equals, let's say, 3 to the x minus 1, like that. All right, so 3 to the x, and then notice x minus 1 is the exponent. All right, so that's going to be a horizontal translation. So what that says is I take the parent function, so take y equals 3 to the x, and shift it horizontally to the, and then notice counterintuitive, so don't say negative go to the left. It's counterintuitive for horizontal, so it's actually to the right 1 unit. To the right 1 unit. Okay, so let's see what that looks like. So if you're asked to graph this by transformations, then you have to do the parent function first. Okay, so let's graph the parent function. So let's go ahead and graph y equals 3 to the x. All right, now we've already graphed it before in a previous problem, but let's just do it again. Just remind us what to do. So to graph the parent function, pick some points. You got to pick some key points on this graph. So if x is 0, 3 to the 0 is 1. If x is 1, 3 to the first power is 3. If x is 2, 3 to the second power is 9. And then obviously when you say 3, it gets larger. So it's like 3 to the third power, which is 27, right? But there's not enough room here. So let's pick some negative numbers. If x is negative 1, I get 3 to the negative 1 power, which is 1/3. If x is negative 2, I get 3 to the negative 2nd power. So remember, no negative exponents. You're going to rewrite this as 1 over 3 squared. That's what that's defined as, which is 1/9. All right. And so we plot those points. So remember, we're plotting the parent function. So we plot those points. And remember, this parent function, there's no number here. So that means that the horizontal asymptote, and I'll put HA, the horizontal asymptote is y equals 0, or the x-axis. So here's the horizontal asymptote for my parent function. So 0, 1's here, 1, 3 is here, and then 2, 9 is, let's see, 3, 4, 5, 6, 7, 8, 9 is here. And then on this side we have negative 1, 1/3, and the negative 1, 1/9. And remember, it never crosses the x-axis, okay? Or I should say, it never crosses the horizontal asymptote. So remember, the exponential function does not cross or touch the horizontal asymptote. It's closer and closer and closer to it. So draw something like this without making it look like it touches or crosses. All right, and then just do the best you can with drawing this part. So it rises in this case very rapidly as you move to the right, just like this. So it's an increasing function. We knew it was increasing because 3, the base, is greater than 1. All right, now what I'm going to do now is graph this. So to graph this, I've got to take the parent function and shift it horizontally to the right 1 unit. So every point, I'm going to shift to the right 1 unit. And I want you to notice is that, as I see there's no number here, right? So you may say, well, how do you graph the horizontal asymptote? Well, the horizontal asymptote for this parent function is the same as a horizontal asymptote for this, right? So notice f of x equals 3 to the x minus 1, I can write as plus 0. So here's your horizontal asymptote. So the horizontal asymptotes are the same. All right, so all you're doing is just shifting this graph. The horizontal asymptote is the same as this one because there's no number out here. Actually, there's a number you can think of as 0, but you don't see any other number other than 0. So that's your horizontal asymptote, y equals 0, which is the x-axis. So all you're doing here is just shifting the graph to the right. So let's go ahead and do that. So every point that's on here, I'm going to shift to the right, 1 unit. So 1, 1, 1, 1. And it looks something like this. All right, do the best you can right here. See, it gets a little tight right here. And then over here, make sure you draw the arrow. And then do the best you can over here. Like this. Now, whenever you move this part to the right, it kind of looks like every point here is moved to the right 1 unit, right? Just like this, okay? And then over here it gets a little tight, so it's a little bit harder to see that at this point's moved 1 unit to the right, this point you've moved 1 unit to the right, and so on. But that distance here should be the same all across. All right, so there's the orange graph is f of x equals 3 to the x minus 1. All right, so let's look at another one. So let's do this one. So let's graph. So this should be the next problem. So let's graph this. Let's graph f of x equal, let's say 2 to the x plus 3. 2 to the x plus 3. So let's go and graph this. All right, so to graph this using transformations, first of all, we're going to graph the parent function. Graph the parent function, which in this case will be y equals 2 to the x. And so once I graph the parent function, remember x plus 3 tells me that's a horizontal shift. So I'm going to take this parent function, I'm going to shift it 3 units, but you got to be careful which way. So it's counterintuitive or horizontal. So don't say, well, since that's plus 3, I go to the right. You actually go the opposite way. You go to the left. So once we graph the parent function, then we shift the parent function 3 units to the left. Okay. Now, right away, you note that I'm hoping you see this. You see there's no number right here other than 0, right? So I'm hoping you see that the horizontal asymptote here is the is the x-axis, or y equals 0. I'm hoping you see this. See that plus 0 right here. All right. So the horizontal asymptote for the parent function is going to be the same as the horizontal asymptote for the function I want to graph, because this is understood to be plus 0. So y equals 0 is the horizontal asymptote, which is the same thing as the x-axis. All right, so let's go ahead and graph the parent function. So on a coordinate plane, remember you're going to want to graph y equals 2 to the x first. So do a t-table, just like this. So I want you to graph the parent function. So you're going to graph the parent function using a t-table. So if x is 0, I get to the 0, which is 1. And before we move on, I want you to notice my base is 2, which is greater than 1, right? So should the function be increasing or decreasing? It should be increasing. Okay, as you go from left to right, your function's increasing rapidly. So when x is 0, you get y is 1, 2 to the 0. When x is 1, you get 2 to the first, which is 2, right? When x is 2, you get 2 squared, which is 4. And then when x is 3, I get 2 cubed, which is 8. And then all of a sudden, when you do 4 and so on, it gets too big. It gets beyond our grid. So let's do some negatives. When x is negative 1, I get 2 to the negative 1, which is 1/2. When x is negative 2, I get y equals 2 to the negative 2, which is 1 over 2 squared, which is 1/4. And so we have enough points here to graph the parent function. So I have 0, 1, which is here. I have 1, 2, which is here. I have 2, 4, which is 2, 3, 4, which is here. I have 3, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right. And on this side, I have negative 1, 1/2, and then negative 2, 1/4. And so notice it gets closer and closer and closer to the horizontal asymptote, which is the x-axis. Okay. So remember the parent function, there's no number here other than 0. And so we know that the horizontal asymptote is y equals 0, which is the x-axis. Now on this side, I want to make sure you connect those carefully. So it rises very rapidly like this. Okay? All right, so what I've just graphed, though, is the parent function, y equals 2 to the x. Now what you're going to do is you're going to use transformations to graph this. And so that's this right here. So this says I take the parent function and I shift it to the left 3 units. To the left 3 units. And by the way, this right here, the horizontal asymptote, since I'm not moving up or down, the horizontal asymptote stays the same. Okay? So all you're doing is shifting the graph 3 units to the left. This stays the same because you're not moving up or down. All right, so 3 units to the left. See this point right here? Go 3 units to the left. 1, 2, 3. This point here, 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 1, 2, 3. All right, and do the best you can. Make it look like it's getting closer and closer and closer to the horizontal asymptote. And don't make it look like it goes back up. Some of you do it very quickly. You want to graph this quick and move on to the next problem. That you mistakenly make it curve up. It doesn't do that. So if you do that, mathematically that's not correct. All right, so don't lose any points. Just do something like what I just did. Don't make it curve up. Don't make it curve down to where it looks like it crosses the horizontal asymptote, because you know it does not. Okay, so do something like this, and then do what I'm doing. So I'm gonna just make sure. See how I'm kind of doing one little piece at a time like this. Just make sure you have something that looks like this. And don't forget your arrow. Okay. So again, don't make it look like it curves up. Some students do, and that's incorrect. Because it doesn't curve up, it gets closer and closer to the x-axis without crossing it. So see these y values are getting closer and closer to the x-axis, which is y equals 0. So my y value is getting closer and closer and closer to 0. Same thing here. gets closer and closer and closer to 0. Your y values are getting smaller and smaller as x goes to negative infinity. As x goes to positive infinity, your y values are getting larger in both cases, rapidly. All right, so the orange graph is f of x equals 2 to the x plus 3. All right, let's do one more. So notice that the base here is 2, so you knew it was rising rapidly, right? So what if the base is, let's say, 1/2? So let's look at 1/2. So let's do 1/2. All right, so we're going to graph f of x equals 1/2 to the x minus 3 using transformations, using translations in this case. All right, so since the base is 1/2, which is less than 1, we know that it's going to decrease. It'll do something like this, okay? So it's going to decrease. It'll go down like this. All right, now notice that the horizontal asymptote is the x-axis, right? And so when thinking about what you see here using translations, this says I take my parent function. So we're going to first graph the parent function, which is y equals 1/2 to the x, okay, the parent function, and then shift this, and then remember x minus 3, so we're going to shift it 3 units to the right, okay? So shift, and then shift this 3 units to the right, okay? All right, so let's go and do that. So let's graph the parent function, which is 1/2 x. All right, so y equals 1/2 x. All right, t-table. If x is 0, y equals 1/2 to the 0, which is 1. If x is 1, y equals 1/2 to the first, which is 1/2. If x is 2, I get y equals 1/2 squared, which is 1/4, right? Now let's do some negatives. If x is -1, I get y equals 1/2 to the -1. So remember, we have to make that exponent positive. So to get that exponent to be a positive 1, I have to take the reciprocal of the base. So the reciprocal 1/2 is 2, so it becomes 2 to the first, which is 2. If x is -2, I get y equals 1/2 to the negative second power, same thing. I got to make this exponent positive, so the reciprocal of the base is 2 squared, that becomes 4. If x is -3, I get y equals 1/2 to the negative third. I need to make that exponent positive, so I'm going to take the reciprocal of the base. So that's 2 to the third, which is 8. All right, so we have enough here to graph this exponential. So 0, 1, 1, 1/2, 2, 1/4. So 1, 1/2, 2, 1/4. So, and by the way, so remember the horizontal asymptote. Let me put it HA, the horizontal asymptote. Let me write it out actually. The horizontal asymptote is y equals 0, or the x-axis. All right, so I'm denoting that by a dotted line like this. All right, so notice that on this side, the graph gets closer and closer and closer to the horizontal asymptote like this, without crossing it. All right, on this side, I have the point -1, 2, -2, 4, 2 4s here, -3, 8, -3, 8. So 4, 5, 6, 7, 8 right here. All right, and so just do the best you can. Kind of do it like this, like I'm doing it. So we're just kind of very carefully getting closer and closer to this. Okay? All right, so remember, that's the parent function. So that's y equals 1/2 to the x. Now what I want to do, though, is graph this using translations. So I take the parent function and I move it 3 units to the right. Okay, so move it 3 units to the right. So every point on that graph, I'm going to move 3 units to the right. Now, since I'm moving to the right, the horizontal asymptote stays the same. It's just the graph here that I'm shifting 3 units to the right. Okay, so use the points that you already used here to help you. So this point here, 1, 2, 3. 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 All right, and so you have this. All right, so again, remember, don't make it go looking up. All right, I mean moving up like this, because you know it doesn't do that. So don't lose any points. Kind of like this, and then over here, let's see. Just do the best you can on this side. So as you go to negative infinity, your graph rises rapidly up. But notice I said as you go to negative infinity, your graph rises up, right? But remember, when talking about increasing, decreasing, we always go from left to right. So as I go from left to right, my y values are decreasing. You can even see it here, right here. See 1, 1/2, 1/4. If x is 3, you would get 1/8, and so on. See how it's decreasing? Your y values are decreasing. You're going from large y values to small y values. In fact, remember, you're always getting closer and closer and closer to the x-axis, which is y equals 0. All right, so this right here is f of x equal 1/2 to the x minus 3 using transformations. All right, now let's look at this. I just want to combine a couple of things just to remind you what to do. All right, so if you look at this one here, so notice there's a couple of combinations here. So you have a vertical translation and you have a horizontal, right? So let's talk about the parent function. So I want you to do this using translations. So first we're going to graph the parent function. So we're going to graph y equals 2 to the x. Once we do that, we're going to do the horizontal next. So the horizontal translation is 2 units to the left, right? Okay, so then shift y equals 2 to the x 2 units to the left. All right, and now I want to remind you what's happening. So when I shift it to the left, I've now graphed this. Okay, so you now have y equals 2 to the x plus 2. So now we're going to do next is we're going to take this now and we're going to shift it down 3 units. Now take y equals 2 to the x plus 2 and shift it down 3 units. And so once you've done that, you've now graphed this. So we now have the graph of f of x equals 2 to the x plus 2 minus 3. All right, so those are your steps. So we're going to first graph the parent function. Then we're going to take the parent function. I'm going to shift it 2 units to the left, all right, which now is going to be this graph here. And then to get this, the next step is to move it down 3 units, this right here. Move that down 3 units. And then once we do all that, then we have the final graph. All right, so let's go ahead and do that. So first of all, let's graph the parent function. So the parent function is y equals 2 to the x. So using a t-table, when x is 0, remember you got to use some key points. When x is 0, 2 to the 0 is 1. When x is 1, 2 to the first is 2. When x is 2, 2 squared is 4. When x is 3, 2 cubed is 8. When x is negative 1, I get 2 to negative 1, which is 1/2, right? When x is negative 2, I get 2 to negative 2, which is 1 over 2 squared, which is 1/4. So what I have is this. I have 0, 1, 1, 2, 2, 4, 3, 8, and over here, negative 1, 1/2, and so on. So it looks like this. And here's your horizontal asymptote. Notice the dotted line, which is the x-axis. And get something that looks like this, right? Okay, so that's y equals 2 to the x. So then the next thing I want to do is I want to shift this now 2 units to the left. All right, so when I shift that 2 units to the left, notice my horizontal asymptote stays the same because I'm moving it to the left. So I'm going to move every point to the left. 1, 2, 1, 2, 1, 2, oops, yeah, 1, 2, and then 1, 2. Okay, so now that looks like this. just like this. Oops. You have a pencil, so you can always erase this. And then make it look like this. As you go from left to right, this rises rapidly. All right, so this part here is y equals, so make sure your equation's correct. All right, so remember you're moving this 2 units to the left. So that means this graph here, this blue graph, is now 2 to the x plus 2, okay? Which is what this is. Now we're going to take the blue graph, I'm going to shift it down 3 units. Now when you're shifting down 3 units, we shift the horizontal asymptote down 3 units as well, okay? So this horizontal asymptote, I'm going to shift down 3 units. 1, 2, 3. So here's my new horizontal asymptote right here. So that's y equals -3. You know the horizontal asymptote is y equals -3 because this is what you see, right? That's your horizontal asymptote. And then all we do now is we take the blue graph and we shift it down 3 units. So every point on the blue graph, we're going to shift down 3 units. Let's do an easy one here. So this is easy right here because it's on the intersection of these two grids, these two lines. 1, 2, 3. 1, 2, oops, 1, 2, 3. 1, 2, 3. And then right here, 1, 2, 3. And right here, that's going to be, this looks, let's just estimate this. 1, 2, 3, right here, let's say. Okay? All right, so then I get something that looks like this. And then like this. All right? Just make it look as good as you can. You have a pencil, so erase if you have to. So every point I move down 3 units. Now right here, when you move it down, it doesn't look like this space is the same. It should because it's vertically, you're moving vertically down, not horizontal. You're moving vertically down. All right, so you see when you move horizontal, that space here looks pretty good, right? But when you shift down, that's not true anymore because of that curvature right here. But you are moving it down 3 units because look, 1, 2, 3. 1, 2, 3. You see that? Moving vertically down all 3 units each time. All right, so the orange is your final graph. So you're going to say, this was what, f of x? You're going to say f of x equals 2 to the x plus 2 minus 3. And that's it. So that is how you're going to graph exponential functions using vertical translations and horizontal translations.